This week, we're going to look at the summaries, and summaries really are the key to this class. This is the focus of this class. And I'm also a firm believer that so I'm going to start dropping vocabulary words here and there. And eventually, where we're going with this is we're going to look at this idea called a sampling distribution. What is a sampling distribution? So when you, and you, I'm sure, are very aware of this, when you sample from a population, every time you sample, you will arrive at a different summary. So the sampling distribution, what is this? It contains all possible summaries So it contains all possible summaries from a fixed sample size. That could have occurred. Notice the key word here, could have occurred. So when we actually sample, we'll experience one thing, but the sampling distribution is the collection of everything that could have happened. Sometimes I like to think of this as the, multiverse. If you're a fan of science fiction, or, more, if you're not into that, multiple realities. Do we have multiple universes attached to this one? Okay. But now we're just going to look at more mundane thing. So keep this idea in mind. So we're going to look at summaries, but we're not going to look at, it's not an exhaustive list of summaries. We're only going to look at summaries that you are already familiar with and can comprehend without too much trouble. And really the goal, the reason for this is because our end goal is to make you aware of this thing called the sampling distribution. Later on, I will share with you a video I made during the COVID pandemic concerning an article in the New York Times, where again, it had to do with the efficacy of the COVID-19, the Pfizer COVID-19, drug. But we're going to start here with something very, again, mundane, but important. The median. In order to look at the median, what is that we need to do? Well, in order to make sense of data, we need to condense. So this is actually in general here. We need to make sense of data. We need to condense information either graphically or numerically. One important type of summary attempts to find the center. There's more than one type of summary that finds the center. We're about to do that. One such summary is the literal center of the data, which is called the median. So the median is a summary, and its purpose is to find the center. But you have to kind of start thinking about what do we mean by the center? Okay, what does that mean, the center? Here's the thing, distribution. What does distribution really mean? It's a word we throw about. I'm sure you recognize it, but what is a distribution? So let me actually define this for you. Just the components. What is a distribution? The distribution has two parts of it. Contains outcomes. And what's the other? The chance of those outcomes. Chance, or I'm going to throw another word here, frequency of those outcomes. That's what a distribution is. Let's again come back to the median. To find the median, you first need to order the data from smallest to largest. You can also do from largest to smallest, but again, the way we think is going from small to large. So that's just the way we've always done things, and most likely that's the one thing you feel more comfortable with. So we go from smallest to largest, so order from small to large. And again, we depending on where you grew up at, we read from left to right. So if that is the case, then it makes sense to go from smallest to largest, left to right. Once the data is ordered, the following formula finds the position of the median. Okay, but this is just the position. So the formula for the position of the median is this, n plus 1 divided by 2. But now the question is, what is n? Where n is the sample size. The sample size can only be symbolized by the letter n in statistics. So you see the letter n in statistics, it only means one thing, sample size. It cannot mean anything else. Sometimes you'll see capital N, but most of the time you see lowercase n. Sometimes if you see both, then they might say, well, this is the population sample size, or well, the population size, and this is the sample size. Sometimes you see that distinction, but n can only mean one thing, how big your sample is. Find the median of this. So first thing we do is this in order? How many do we have, by the way? Well, let's figure this out. Is this set order? That's the thing you want to first look real briefly. 5, 12, 15, 18, 18, 23, 25, 28, 44, 45, 59. Yes, it is ordered. Fantastic. So the next thing I want to do, well, how big is the sample size? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what we're going to now determine is the sample size is 11. Great. So here's how this works. I want to find the median now that it's ordered position of median. How do we find the position of the median? Well, we can usually find this data set's rather small, so I won't need this, but I want to illustrate how this formula does work. So 11 plus 1 equals 2. So that's 12 over 2, which is 6. So what this is saying is we need to count to position 6. So from left to right, this is position 1, position 2, position 3, position 4, position 5, position 6. Bingo. Position 6 is 23. The median equals 23. Sometimes symbolized as m equals 23. So if you see that's most likely the median when they're mentioning. So what does the median do? Well, notice if you find the median, it splits the data in half. Now, to do this, notice I'm going to have to exclude this value. But now my data is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, as long as I exclude that. So of course, this is not going away. This is still part of the data set. But what the median does is this is a position such that half of the information is above this number and half of the information is above that number. Okay, that's all it is. So of course, to do that in this case, I had to sort of remove this one sort of mentally, but half is below this number, half is above. So that's what the median does. It literally is the center of the data. Again, if, I have one more thing. If somebody asks you what percentage of values are below the median, the answer is 50%. So 50% of the data is below the median. Another thing we could ask is, what is the median? Why would we want to find the median? Well, there's some certain characteristics that we'll look at later that the median has, and it becomes a useful number. But again, it's the center. Now let's look at this set here. Find the median of this set. So again, is this ordered? If this one is the data set ordered. And go 1, 2, 3. Sorry, 45, 58, 51, 68. Yes. Yes, it's in order. So I check yes. Yes, it's in order. Perfect. How many data values do we have? 1, 2, 3, 4, 5, 6, 7, 8. So in this case, looks like 8. Check one more time. 1, 2, 3, 4, 5, 6, 7, 8. So now let's do the position of median again. Position of median. So notice this is not the median, it is the position. So the position is going to be 8 plus 1 divided by 2, which equals 9 divided by 2, which equals 4.5. So now notice the result is fractional. Before it was 6, I can count to 6. But how do I count to 4.5? So what this interpretation is that the median is between position 4 and 5. The median is between position 4 and 5. And notice, because this is half, what it's saying is not only is it between position 4 and 5, it is halfway between position 4 and 5. If the median is halfway between position 4 and 5, what do we do? What's the sensible thing to do to find the median? So let me just, again, enumerate this. 1, 2, 3. Again, enumerate means to put in order. And then let us say this is number 1, number 2, number 3, 4, 5, 6, 7, 8. So position 4 and 5, the median is right here. So notice in this case, the median is not at one of the values. It is between two actual values. So the median doesn't have to be an actual data value. But the sensible thing to do is to find the mean. or what we known as the average, just because I think I'm going to cause confusion. We're going to find the median by finding the mean of those two numbers. So, but the median will be, okay, take 261, 268, positions 4 and 5, divide them by 2. And when I do that, I get 264.5. So that is the median. The median is 264.5. So notice again, count 1, 2, 3, 4, 1, 2, 3, 4. The median has split the data in half. 50% of the information is below that number. 50% of the information is above that number. Okay, and in this case, it's not one of the data values. So the median is either going to be one of the data values or the average of two numbers. Notice if it's odd, it should be one of the data values. If it's even, it should be an average of two things. The sample size is odd, the median is the middle number. Otherwise, if it's even, so otherwise it means n is even, sample size is even, it is the average of the two middle numbers. The median divides the data in half. And notice if it's one of the numbers, and literally doesn't. I mean, you have to omit that, do that, but in half. So 50%, but really the better way to describe this is that 50% of the data is below the median and 50% is above the median. So it's like a marker, and it's a very, very, very useful marker. Have I used it in my life? Yes. Yes, I use it. I'll share a story of something that I use it all the time, but it's a nice starting. In real estate, the median price of a home is what's quoted to you. So I not realize that half the homes prices are above this number and half are above. So it's a nice simple summary to start making sense of the distribution of the data. Another summary that attempts to find the center of the data is the mean, known in everyday language as the average, and we'll look at this later.